All right, so everyone, the last time we went over the math review because math is so important. We have to have sound understanding in math to understand physics. So this time we're going to pick up from where we left. We're going to use all those beautiful physics formulas to we're going to make our own example to understand every single topics of Newtonian physics. That's our goal. By end of this course, you should be able to answer any physics problem, especially a Newtonian physics problem. Someone may give it to you. So let's do the first one. What is first one says? First one asks us to calculate average velocity. There is no quotient given, so we're going to make our own quotient. So first formula is simply the average velocity is d over t. So using this formula, we should be able to make our own problem. That's very important. Why? That way we're not going to understand the formula. We will be able to see what's inside the formula, and by using this simple formula we will be able to make quotient. When you can make quotient, you should be able to solve the quotient. So let's make a quotient. Let's say Dr. Kabat went out to a bike trip, I guess. Okay, he is very concerned about his health, so he went out to a bike trip for 1.5 hours. And the position function, I guess, we can write 40 over 3 t squared. And position function, we can write p of t, all right? 20 miles of the trip, we saw a speed sign limit. Speed sign limit of 25 miles per hour. All right. Since it is bike, 25 miles per hour is quite a speed. So find his average velocity, and this is A. B is, did he break the law? All right. So in this question, as you see that we will be able to understand why calculus is so important to understand the physics problem. In fact, you know, Newton, like 375 years ago, quite wasn't able to solve the physics problem because there was a problem of 0 over 0. The algebra and help us understand or solve 0 over 0 problem. So Newton quite got a start. So he had to invent calculus to solve this problem. Now we're gonna use what Newton used like 400 years ago, and we're gonna see that whether Dr. Kabat break the law. So let's first find his average velocity. To find the average velocity, we have to know his distance. So let's draw first. All right, so that's where he begins, that's where he ends. So let's see, t naught is 0 and d naught maybe also is 0, right? Maybe there is there is him, I guess, and there is his bike, all right, and he is biking along the way, and on 20 mile, in 20 mile he saw a speed limit sign which is 25 mile per hour, and it took him, so T final is 1.5 hour, which is 3/2 hour, right? What is D final? We don't know, we will find out. We can say this is D2, right? We can say this is D2, and what is T2? We don't know yet. We'll find out. All right. So the step 1, we have to find D final, the distance final. Distance initial is 0, maybe he's home, so 0. Distance final maybe Central Park or somewhere else. We will find out. How we're gonna write is step 1, finding df. We can use the position function to find the df. So we can write p of t equal to 40/3 t square. One way we can find the d final just simply by putting how long it took him to go all the way there. That's how we can find the distance. So p 3/2 equal to 40/3 3/2 square, right? So 40/3 times 9/4. So 4 goes to 40 10 times, and 3 goes to 9 3 times. So 10 times 3 is 30 mile. So he is 30 meters, right? So the final distance is 30 meters. Well, in this case mile, we are using mile. The question is using mile. So let's keep the unit correct, mile. Okay. So now we can find the average velocity. So average velocity is delta d over delta t. Here is average velocity. That's the first formula. Finally, we are doing something physics. So that is delta d is d2 minus d1, t2 minus t1. All right. So what is d2? D2, or we can say d final. Let's say d final and d naught, t final and t naught. So you see that d final is 30 mile. So let's put 30 mile here. And d initial you see 0. So let's put 0. And t final you see 3/2. And t initial, what do you see? 0. Right? So 30 mile times, now you're going to flip it, all right? So it's going to be 2/3 hour. So now let's use the different color. 3 goes to 30, 10 times is 20 mile per hour. So his average velocity is what? 20 mile per hour. Does that mean he didn't break the law? Not necessarily, because he could, the 20 miles per hour is just his average velocity. Average velocity does include everything you do between starting to end. That includes, like, you stop in a coffee shop, you stop for various reasons. You wanted to take break because you're tired. So average velocity doesn't tell us the whole story. It tells us the part of the story. Maybe he was biking fast here. Maybe he was biking faster here. Maybe he was biking even faster here. Average velocity doesn't tell us that. Maybe at this point he was resting. We don't know. So how we can use the algebra to get the better picture of what was he doing at this point, because We are not interested in what he was doing here, we are not interested in what he was doing here or over here. We are interested in what he was doing over here. But the average velocity tells us what he was doing from beginning to end. That's the big interval. We wanna know what he was actually doing over here, right here. So how can we do that? One way we can do that is by making a small interval. All right. So this T2 we saw. We can find this T2, and then we will be able to make a small interval and try to see what he was doing as he was approaching to 25 mile per hour. As he was approaching to 20 miles. All right. So let's see. What is T2? Let's find the T2 now. How can we find the T2? One way we can find the T2 is make the position function 20. So P T is equal to 40 over 3 T square. Position is 20, so 40 over 3 T square. All right. So now we can multiply both sides by 3 over 40. 3 over 40. Then 3 cancel, 40 cancel, and here we have so here we have 60 over 40, and 0 cancel, 2 and 3, all right, and over here T square, all right. So then T is equal to 3 over 2, all right. What is that gives us? Let's use the calculator. This gives us 3 divided by 2. This gives us 1.22. This gives us T is plus minus 1.22. But we don't care about the negative because the time cannot be negative. Well, maybe it can negative, but this is basic physics. We're not going to worry about that. So this is, we disregard the negative time. We only count the positive time, so we're going to write 1.22. What does that mean? That means when he was at 20 miles, the time was 1.22 hour. Another way to say, it took him 1 point or less than 1.5 hours to get to 20 miles. Okay, so let's use this. Let's use this extra information to make the interval a little smaller. Okay, so let's see what can we call this point? We can call, let's see, this can call be T1. Let's say T1 is 1. If T1 is 1, at 1 hour, how far he come, right? At 1.22 hour, he come 20 miles. At 1 hour, how far he come? D1. Let's find that. At 1 hour, how far he come? So again, PT is 40 over 3 T squared. At 1 hour, let's see how far he come. 40 over 3, 1 square. All right. So it's basically 40 over 3 is 13 times 3 is 39, so 13.3, all right. So 13.33, all right. So that's how far he come after 1 hour or at 1 hour. So it took him 1 hour to come 13 miles, 13 and little bit more miles, all right. So we're gonna use this information to see that what he was doing between this interval, because if we find what he was doing between this interval, it is better than finding what he was doing between the the whole interval because this is very close to 20 miles. All right, so let's see. This is d2, so d2 minus d1 and t2 minus t1. So what is d2? d2 is 20 mile and d1 is 13.3 miles. And t2 is 1.22 hour and t1 is 1 hour. All right. So let's use the calculator. All right. 20 minus 13.3 divided by 0.22, which is 30.45. So he was actually speeding at the rate of 30.45 right on this interval, right on this interval he was speeding 30.45 mile per hour. Was it over the limit? Yes, it was quite over the limit. Does that mean he broke the law? Well, not necessarily, because he could have slowed down as he was approaching to exactly 20 miles, because that's what we care about. He was maybe slowed down. So how do we know exactly what he was doing at this point? Now let's see. Let's call this delta D over delta T, and let's call this, we also already had that, d2 minus d2 and t2 minus t2. What is d2? 20 mile, and d2 is 20 mile, and then 1.22 hour minus 1.22 hour. So 0 over 0. All right. So the algebra doesn't really help us to find out what's going on at this point, right? Because if we make this interval is infinitesimally small, then we get 0 over 0, which is not good. So we have to use calculus. That's annoyed Newton some 375 years ago. So he had to come out with new kind of math we know now as calculus. How did he solve this problem? Let's see. That's what he did. He first draw the position function for this problem. So we already know that y is x squared. Y is x squared is basically like that. So y is, think as if this is y and this is x squared. So then you're going to have like something like that. All right, a parabola, right? Okay. So now here you have, this is your t, this is time, and this is your p. This is time is in a hour, and p is in a mile. All right. So this is half hour. This is an hour. This is 1.5 hour, and this is 2 hour, right? And this is maybe like how many miles? This is 10 mile, 20 mile, 30 mile, I guess, right? Okay, now at 1.5, what was his position? At 1.5, his position was 30 miles, all right? So his position was 30 miles, all right? So let's put 30 here, all right, 30 miles, right? So at 1.5, his position was 30 miles, so we're going to connect that, all right? So this one is T naught, D naught, T naught is 0, D naught is 0, and this is T final is, all right, T final and D final. T final is 3 over 2 and D final is 30 miles, right? Now, We want to know what was happening at when he was at 20 mile, right? 20 mile is 1.22. 1.22 is right here, right? 1.22 is somewhere right here, and 20 is somewhere right here. We want to know what was happening right here. We don't care about what was happening here. We want to care about here. All right, so that's what Newton did. He invented a clever thing, calculus. So he wrote as well. He wrote, this is our this is the formula. We already went over it in the math review, but let's do it again. So as let's do it one more time. This is our t, and this is our t plus h, and this is our f of t, and this is our f of t plus h. This is, we are using p, so let's use p. All right. So we did it in the math review. If you still have problems, so you can watch it over. All right. So let's do that. If h approaches to 0, then limit. If h approaches to 0, then what? P t plus h, all right, minus p t, okay, over t plus h minus t. All right. So t cancel. Now we have limit as h approaches 0. All right. So what is our position function? Our position function is here. All right. Our position function is here. So we have 40 over 3 t plus h square minus 40 over 3 t plus h. I hope I'm not making a mistake. Let's see. 40 over 3, limit as h goes to 0, right? Here you have t square plus 2th plus h square minus 40 over 3 t minus, you distribute 40 over 3 h over h, all right? So now you're going to distribute this to limit as h goes to 0, 40 over 3 t square plus 80 over 3 th plus 40 over 3 h square minus 40 over 3 t minus 40 over 3 h all over h. All right. So let's see. Something needs to cancel. T square th, so 40 over t minus h, so get the math correct. Can I pause it here?
You can.
For 1 second?
Sure. Just start from there.
Okay. We don't have to cut. I'm going to fix it.
Okay. All right, go.
All right. So I realized that we make a mistake over here. Instead of t plus h, we gonna just write 40 over 3 t squared. This is a big mistake, and can't forgive myself for this mistake. All right. So this is just 40 over 3 t squared, right? So now we're gonna have 40 over 3 t squared, 40 over 3 squared cancel. So let's bring this over here, limit as h goes to 0, we have 80 over 3 th plus 40 over 3 h squared over h. All right. So now, what is the GCF? GCF is h. So limit as h goes to 0. All right. So h is our GCF, 80 over 3 t plus 40 over 3 h over h, right? So h is cancelled. So limit as h goes to 0, 80 over 3 t plus 40 over 3 h. And as limit h goes to 0, we left with limit as we don't need to write limit anymore. We're going to write p prime of t equal to 80 over 3 t. And t 1.22 hour, p prime 1.22 hour is 80 over 3, 1.22. And that should be what we got in algebra, or more precise. In algebra we saw he was speeding 30.45 mile per hour. Let's see what calculus gives us. 80 divided by 3 times 1.22, yes, it gives us 32.5 mile per hour. That is more correct than this one. So now we see what calculus help us to find the more precise answer of physics. We see that he was way above the speed limit, and he was actually how many miles above the speed limit? 7.5 miles over speed limit. So he was actually breaking the law. All right, so that's how you see that calculus help us solving the physics problem. The algebra has some limitation, not some, a lot of limitation, but calculus is a strong tool to solve the problem that we need to solve.